Today's video is for the exponential regression notes. So just like we did with linear regression and quadratic regression, we can do the same with exponential functions. So let me kind of switch things around here so we can see everything. So, and we do this the exact same way. So the first thing I'm going to do is just clear my calculator out. And then we're going to go to stat. Okay, in stat we're going to put x values in L1, y values in L2. So we've got -2, -1, 0, 1, 2, and then our y's. Okay, so once we put everything in, we're going to do stat, right arrow key, and then we're going to press, you can press 0 or you can go down to, this is exponential regression here, and you're going to hit enter. Make sure the X list says L1, the Y list says L2, and then you can enter all the way down to calculate. And so what it gives you an A and a B value, and you can write your function off of that. F of X equals A is 2, and then B is 2.5, and then your exponent is X. And again, when you're doing this in the calculator, it gives you the form right here so you know where to plug all your values in. Okay, so now using this, how we need to be able to use this. So a red clay pot was fired in a kiln to a temperature of 2,192 degrees Fahrenheit. The kiln was then turned off, and the clay pot was allowed to cool to a room temperature of 72 degrees Fahrenheit before removing the pot from the kiln and painting it. The table below is a list of temperatures of the clay pot as a function of the elapsed time since it was removed from the kiln. So what we have, ooh, and I put quadratic there, I'm so sorry. That should be exponential to get that fixed. We can use this table and use exponential regression to write us a function. So I'm going to clear out in stat. So x's, which time is an x, goes into L1, and then your y values, or your dependent values, go into y2. So then we're going to do stat, right arrow key, and again I'm just going to hit 0. I can see up at the top here where it says exponential regression, and enter down to that. So my function here is going to be estimated. So I'm going to round this off. So I'm going to do f of x equals 2,187. Let's do 2 decimal places. So 0.63 times 0.85 to the x power. The other thing that I can do is I can create a scatter plot using this data. And so again, you have to just kind of estimate here, see 18, 19, 2000. So 21 is going to be up here, 1 and 18, 60, 3, 13, 45, 5, and 970, 7, and 705, 9, and 5, 2. And so with a scatter plot, you don't have to connect the dots, but you can kind of see the trend of this, where it's going. So using the scatter plot and function you created, answer the following questions. What would the temperature of the clay pot be after 12 hours? So one thing that I can do in my calculator, I can go to y equals, and I can use this function that I created here, 2187.63 0.85 to the x power, and I can go to the table. So hours are our x's, so on my table I can go down to where x is 12 and look at what the approximate. So again, these are approximates, it's not going to be exact. So that pot is going to be about 311 degrees Fahrenheit. Then it says approximately how many hours would it take for the clay pot to reach 72 degrees. So you can use the graphing and the table function. So 72 degrees is going to be a y value. So I could down this, and there's 72 right there, and I can look at the time, X, and it would be about 21 hours.